All right, so the next round of trig equations, I like to call them use trig identity form. All right, to do these after we do that, hopefully we can just factor. It's a quadratic, it's a line after we do all that work. So the reason why we have to invoke a trig identity in these cases is due to the fact that the angle argument for the sine is double and the angle argument for cosine is singular. That's also happening here, right? We have a double angle for cosine and then a singular angle. So we need the angle arguments to be the same. And so in this case, we invoke a trig identity to help us out and to keep the ball rolling. So what do we know about sine 2x? Well, we know that that's 2 sine of x cosine of x plus cosine of x equals 0. So what I'm now seeing, as far as this equation is concerned, both the terms have cosine. So I can factor that out. So once I factor that out, I have cosine times 2 sine plus 1. And then, of course, since it's factored and set equal to 0, I can use the zero factor property. So the cosine of x is equal to 0, or 2 sine of x plus 1 is equal to 0. That one's ready to solve. So in the first rotation from 0 to 2 pi, right, what do we know about cosine? When do we know it's equal to 0 degrees? Well, that's at pi over 2 and 3 pi over 2, sorry about that, in radian mode. In degree mode, this would be 90 degrees and 270 degrees respectively, right? But we're in radian mode at the moment, but I'm just using the degrees to give us perspective. So we already have two solutions to this equation. 90 degrees and 270 degrees gets the job done. Then in terms of the next one, this is telling us that sine x is equal to negative 1/2. And so where's sine equal to a negative value? Well, that's quad number 3 and quad number 4. And the half tells us that we have a 30-degree reference, I believe. Yeah. So in quad number 3, right, a 30-degree reference, that's, what would that be? 7 pi over 6. And in quad number 4, we're talking about 11 pi over 6. Where here we're talking 210 degrees, and here we're talking 330 degrees. We're talking about a 30-degree reference in quad 3 and quad 4 respectively to get a ratio of a half. Negative puts me in quad 3 and 4. All right, so again, hopefully some good review of some previous work in combination with our new work of solving equations. In this case, we had a trig identity. That trig identity gave us a nice factored form, and we can go to town. So what about the next one? So for the next one, we have a double angle of cosine, and that's challenging, right? Because how many different double angles of cosines do we have? We've got 3 of them. So which one of those 3 do I use? Well, let's take a look at the rest of the equation, right? There's a cosine involved. So there's a cosine of x involved, so I basically want the version of cosine that has a cosine of x in it. So we're going to use cosine squared x minus 1. And then we're just going to rewrite everything down. You could use whatever you want, but here's the best choice because now, right, I have everything in terms of cosine x and it's quadratic. So rewriting this, we get cosine squared x minus 3 cosine x minus 1 plus 2 gives us plus 1. So I'm hoping that since it's a quadratic, I'm very hopeful that this factors, because that's probably the best way to solve this. So I know we need 2 cosine, cosine. We need a negative and a negative. I think 1 and 1 works. Negative 1, negative 2. Yep, so there we have it. So invoking our zero factor property, here's what's got to happen. 2 cosine of x minus 1 is 0, or cosine of x minus 1 is 0. This gives us cosine of x equals 1/2. And this gives us that cosine of x is equal to 1. So thinking from 0 to 2 pi, cosine is positive in quadrant number 1 and quadrant number 4. And the ratio of a half, we have a 60-degree reference in those ratios there for cosine. So in quadrant 1, our x value is basically pi over 3. And in quadrant number 4, that would be 5 pi over 3. We're looking at 60 degrees and 300 degrees in degree mode if we were in that. From 0 to 2 pi, what's make cosine equal to 1? Well, that's basically 0, or in degree mode, that would be 0 degrees. So there's our 3 answers in radian mode, and their corresponding 3 answers in degree mode in case we're going to go do that. But again, here we invoked a trig identity, and that pretty much got us going. All right, and so now moving on to the next one, let's put this all together, right? Let's use some algebra, let's use some trig identities to kind of help us get everything all squared away. And again, just like we have done with trig identities in the past, you want to try something. Do something, don't just sit there and look at it. So what do I got here? Well, my first problem is I have a sine function and I have a cosecant function. So I don't have the same function involved, and it's really hard to actually to do something like this in terms of factoring something out because they're not even being multiplied together. So what do? Well, how about we invoke a trig identity, because we know, right, that cosecant is 1 over sine. So at least I have everything in terms of sine now. Clearing fractions, if we now multiply both sides by the sine of x, right, here's what we get. We get 2 sine squared x plus the sine of x equals 1. And so now what I basically have is I have a quadratic in terms of sine. So we're off to the races here. So setting it equal to 0, right, we got 2 sine squared x plus sine x minus 1 equals 0. So again, we're very hopeful that this actually factors, because otherwise we're going to have to use a quadratic formula. And I believe that does the trick, right? Negative times a negative, minus 1 plus 2, yeah. So invoking our zero factor property, we have that. This tells us that the sine of x is equal to negative 1, and this is basically telling us that sine x equals a half. So where's sine positive? Well, that's positive in quad 1 and quad 2. That ratio tells us we have a 30-degree reference. So in terms of our radian mode, because I am in radian mode at the moment, right? 30 degrees, right, is pi over 6. So we're talking about pi over 6 and 5 pi over 6 respectively. Or this would be 30 degrees, 150 degrees in radian mode if we were doing that, right? So where's sine negative? Well, sine's negative basically in quadrant number 3 and quadrant number 4, but we're equal to negative 1. So that's basically telling us 3 pi over 2. And that corresponds to 270 degrees if we were in degree mode, right? That's a 70. Alrighty, so we have 3 solutions to that equation in our first full rotation from 0 to 2 pi. And again, what helped me out here was I invoked as a reciprocal identity, and then I did some algebra, multiplied both sides to clear out the fraction, which ended up giving me a quadratic, and then we can solve it as a quadratic. The next one of the most common mistakes students will do to do this next one is to divide out the tangent of x. You don't want to do that, all right, because if you divide it out, what you end up losing are some potential solutions. So what we really want to do here is basically move some things over. So we get that at the moment. And now what we want to do is actually factor that tangent out. So we get tangent of x, and then tangent squared x minus 3 is equal to 0. So now we're going to get all the solutions. So we get tangent of x is equal to 0 as one of the possibilities, or tangent squared x equals minus 3 is equal to 0. So this one's ready to solve, right? So when's tangent equal to 0? Well, in the first rotation, right, that occurs at 0 and at pi, or 0 degrees and 180 degrees respectively. So that's what makes tangent equal to 0 in our first rotation. Over here, we have the tangent of squared x equals 3. Taking a square root, the tangent of x is plus or minus the square root of 3. So that basically tells us we have negative square root of 3, or we have tangent of x equals the square root of 3. The tangent is the square root of 3 at a 60-degree reference, right? So we have the 60-degree reference, and since we're negative and positive, this means that we're in quad 3 and quad 4, and this puts us in quad 1 and quad 2. So we actually have a solution in all 4 quadrants with a 60-degree reference. So we're looking at, if with a 60-degree reference, that basically means we're pi over 3. So pi over 3, there's your quad 1, 2 pi over 3, there's your quad 2, 4 pi over 3, there's your quad 3, and then 5 pi over 3, there's your quad 4. All right, so we have these 2, and we have those 4, so we actually have 6, all right, solutions in the first rotation for this guy. And you can imagine if we would have divided out the tangent of x, we would have lost those 2, and we would have only been solving that. So fight that urge to divide out. You usually don't want to divide by the thing you're trying to solve for. And in this case, we're trying to solve for tangent of x. So dividing, we would have lost some solutions. Kick things over and factor, factor, factor. Use those algebra skills. All right, so there's a second round of all this. So we invoked some trig identities, did some quadratics, solved some lines. So you can see it kind of all evolving and coming together as one full thing. So some tougher equations coming in the next round. I'll see you guys then.